Alright, so we're going to talk today about the imaginary number, which is what we call I. I is defined to be the square root of -1. We call that imaginary because there's no real number that you can multiply it by itself and get a negative. So we call that answer I. And so what this can be used for is it can be used to simplify square roots with negative radicands. The first step is just to rewrite it as a square root with a positive radicand followed by I, and then simplify the radical. So I've got three pretty simple examples here. First one is the square root of -9, and all that I'm going to do for this is I'm going to rewrite it as a radical with a positive 9, and I'm going to put an I on the end, and that'll make it a little bit easier to work with, because now I can just simplify the radical, and the square root of 9 is 3, so then I just tack an I onto the end, and that's it. That's my final answer. 3I is the simplified version of that. Okay, next one, same type of thing, square root of -20. I'm going to rewrite that as the square root of 20 followed by an I. And square root of 20 can be broken down into 2 rad 5, and then I tack the I onto the end. And that's all I can do. So that's my simplified answer there. Now, common mistake there would be to just call the answer 20I or something like that, but that's not what it is. You have to just put the I out and then simplify the radical like normal. Okay, last one, square root of -11. I'm just going to rewrite by making that square root of 11 I, and then 11's prime, so it actually can't be simplified anymore, and I have my final answer. It's square root of 11 I, which means square root of 11 times I is really all that it means, but that's the idea. So that's how you can simplify a radical that has a square root, that has a negative radicand. Alright, so one thing that's an interesting extension of this is looking at the powers of I. I know what I to the first is. I to the first would just be I. Anything to the first is I, or is itself. So I to the first is I, which is the square root of -1. Well, then if I square that, I know that squaring a square root would only leave the radicand. So I squared would also be -1. What I'm interested in figuring out is what happens if I continue this. If I was to look at, say, I to the third. Well, I to the third would just come from multiplying I squared by another I. And I squared is -1, so -1 times I is negative I. Okay, let's keep on going. I to the fourth would be to take -3, I to the third, which is negative I, and multiplying it by another I. But negative I times I would be negative I squared. And we know that I squared is -1, so -1 actually comes to 1. Which means when I get to I to the fifth, and I just multiply I to the fourth by another I, I'm coming back to I, which means the cycle has started again. You see, every time you have 4 i's multiplying together, it's just going to give you a total of 1. And so that's actually really, really convenient in evaluating any power of I. It's going to be one of these 4 things. It's either going to be I, -1, negative I, or 1, because then the cycle starts again. So again, this is useful for any power of I, such as I to the 20th. I want to look for groups of 4 here. I want to think about every group of 4 is really just going to be the same thing as 1. So I could think of I to the 20th as I to the 4th, I to the 4th, I to the 4th, I to the 4th, I to the 4th. Our laws of exponents would allow us to just add these 5 exponents together, 1, 2, 3, 4, 5, and that's the same thing as I to the 20th. But each one of those is really just 1. which means I to the 20th is 1. Okay, that's pretty convenient. I to the 15th, we could do kind of a similar way. I like my groups of 4, but once I do 3 groups of 4 here, I can't do another group of 4. That'd be too many. So what I'd have left there, because that would account for 12, would just be I to the 3rd. Now, the first 3 things all become 1, and I to the 3rd, as I can see in my list, is negative I, which means I to the 15th is just going to be negative I. It's the same thing as I to the 3rd. Now, certainly I don't want to list out all these groups of 4 for 314, for I to the 314th, but it actually doesn't matter how many groups of 4, because every group of 4 just accounts for a 1. They're all going to multiply together and just be 1. So what I'm really interested in is what was left over. So I'm actually here looking at division and the remainder. So if I do 314 and divide it by 4, I don't care about the quotient, which is pretty easy to find. It's going to be 3, bring down the 4, and that's going to be 8, 32, 2. What I'm interested in is actually the remainder of 2. What this division means is that I have 78 groups of 4. So I could write I to the 4th, I to the 4th, I to the 4th, 78 times. But all of them just become 1, so it doesn't matter. What does matter is what's left over. And it's really the same thing as I to the 2nd, because 2 is the remainder. And based on my list, therefore, I know that it's going to just be negative 1. So there you go. That's how you use the powers of I. Once you learn the list or know how to generate the list, you can figure out any of the powers. All right, so now let's just take a look at what we can do with I. We can do some addition, some subtraction, multiplication, division, any of these operations. So we're going to start with the square root of negative 16 minus the square root of 49. I'm going to simplify each of those radicals first. So I'm going to take the negative out and put an I at the end, make it just a positive radicand. I'm going to do that actually in both. And that's going to give me, when I reduce, 4I minus 7I. And for addition and subtraction, we basically act as if I was a variable. And that's going to leave us with negative 3I. And that's my final answer there. With addition and subtraction, we really treat it very similarly to a variable. And we're actually going to do the same type of thing with multiplication. It's really important here that you do not make this the square root of negative 4 times negative 25, because that would be the square root of 100, which would just be 10. So that's really important that you don't do that, because you actually have to simplify each radical in terms of bringing the I out first. It makes a really big difference. I mean, I guess it won't look like a big difference, but it really is. What happens here is you take the square root of 4I times the square root of 25I, and that reduces to 2I times 5I, which is going to be 10I squared. But we remember from before that I squared is actually negative 1. So 10 times negative 1 should equal negative 10, and that's going to be my final answer. So not the 10. I got to make sure I include the i's there to get I squared to ultimately make my answer negative. Okay, last problem that I want to look at is just a division. 2 over 3i seems fine, but remember that I is a square root, and we can't have a square root in the denominator. The way that we deal with that is we multiply, we don't have to worry about the 3i, but just multiply top and bottom by I. That's going to give you 2i over 3i squared. But once again, we remember what I squared is. That's negative 1. And so our final answer here is negative 2i over 3. And of course that negative could go in front of the fraction with the 2i or with the 3. Any of them would be fine. But there you go. That's just how you can do some operations. So now you should be able to do some practice, solve equations, and simplify your answers, and go from there.